theory, it is the physics that describes the microscopic world. So it's the physics that describes atoms and the makeup of atoms, electrons and protons and neutrons, and elementary particles like photons and crazy particles like neutrinos. So all of the microscopic world, the constituents of matter and energy, are described by quantum theory.
Known as quantum computing. This involves harnessing the power of physics at its most basic level. Unlike the computers we are familiar with we use today, a quantum computer holds the potential to be faster and more powerful. This innovation is expected to change every industry and make problems that are impossible to solve today something that can be solved in a matter of days or weeks. Efforts to develop a commercially available and practical quantum computer are being pursued around the world. Because of the tremendous costs involved in developing a suitable environment for a quantum computer to operate, many of these efforts involve government support. Both the European Union and China have pledged or already have spent billions to develop a quantum computer. In the United States, development of quantum computer is proceeding at the academic, governmental, and private sectors. In addition to larger and familiar technology companies, smaller startups are also leading efforts in this area. We're fortunate to have one of these startups, IonQ, to testify today. Although a quantum computer holds a tremendous potential to solve previously non-computable problems, there are skeptics who question whether it will be possible ever to develop such technology. We look forward to our witnesses giving us their thoughts on this question. On the other hand, some fear that the threat such a computer would pose to traditional computing model. Especially when it comes to encryption and data security, some fear that a quantum computer would make it nearly impossible to keep future computers secure. Data security and consumer privacy are key concerns of this committee. We also look forward to our witnesses addressing this issue as well. Quantum computers hold tremendous potential to help solve problems involving the discovery of new drugs, developing more efficient supply chains, and logistics operations, searching massive volumes of data, and developing artificial intelligence. Whichever nation first develops a practical quantum computer will have a tremendous advantage over its foreign peers. We hope our witnesses will help us examine the state of the race to develop a quantum computer and how the United States is doing in that race. This is obviously a very dense subject.